Chandrayaan-3 is on schedule and smooth sailing continues, the Indian Space Research Organisation, Isro, said in its latest update on Tuesday. The space agency also shared images of the moon captured by lander position detection camera from an altitude of about 70 kilometers. With 1 day to go, Isro tweeted, the Mission Operations Complex, MOX, is buzzed with energy and excitement. Isro's ambitious third moon mission Chandrayaan-3's lander module, LM, is all set to land on the lunar surface on Wednesday evening, as India eyes to become the first country to reach the uncharted south pole of Earth's only natural satellite. The LM, comprising the lander, Vikram, and the rover, Pragyan, is scheduled to make a soft landing near the south polar region of the moon at 6:04 p.m. on Wednesday. If the Chandrayaan-3 mission succeeds in making a touchdown on Moon and in landing a robotic lunar rover in Isro's second attempt in 4 years, India will become the fourth country to master the technology of soft landing on the lunar surface after the US, China and the erstwhile Soviet Union. Isro released footage of the lunar surface as captured by the Lander Position Detection Camera, LPDC, from an altitude of about 70 kilometers on August 19. The LPDC images assist the lander module in determining its position by matching them against an onboard moon reference map. Chandrayaan-3 is a follow-on mission to Chandrayaan-2 and its objectives are to demonstrate safe and soft landing on the lunar surface, roving on the moon, and to conduct in situ scientific experiments. Chandrayaan-2 had failed in its lunar phase when its lander, Vikram, crashed into the surface of the moon following anomalies in the braking system in the lander while attempting a touchdown on September 7, 2019. Chandrayaan's maiden mission was in 2008. The 600 crore rupees Chandrayaan-3 mission was launched on July 14 onboard launch vehicle Mark III, LVM-3, rocket, for a 41-day voyage to reach near the lunar south pole. The soft landing is being attempted days after Russia's Luna 25 spacecraft crashed into the moon after spinning out of control. After the second and final deboosting operation on August 20, the LM is placed in a 25 km by 134 km orbit around the moon. The module would undergo internal checks and await the sunrise at the designated landing site, Isro has said, adding that the powered descent, to achieve soft landing on the moon's surface, is expected to be initiated at around 5:45 p.m. on Wednesday. The critical process of soft landing has been dubbed by many including Isro officials as 17 minutes of terror, with the entire process being autonomous when the lander has to fire its engines at the right times and altitudes, use the right amount of fuel, and scan of the lunar surface for any obstacles or hills or craters before finally touching down. After checking all the parameters and deciding to land, Isro will upload all the required commands from its Indian Deep Space Network, IDSN, at Byalalu near here, to the LM, a couple of hours before the scheduled time touchdown. According to Isro officials, for landing, at around 30 kilometers altitude, the lander enters the powered braking phase, and begins to use its 4 thruster engines by retro-firing them to reach the surface of the moon, by gradually reducing the speed. This is to ensure the lander doesn't crash, as the moon's gravity will also be in play. Noting that on reaching an altitude of around 6.8 kilometers, only 2 engines will be used, shutting down the other 2, aimed at giving the reverse thrust to the lander as it descends further, they said. Then, on reaching an altitude of about 150 to 100 meters, the lander, using its sensors and cameras, would scan the surface to check whether there are any obstacles and then start descending to make a soft landing. Isro Chairman S. Somanath had recently said the most critical part of the landing will be the process of reducing the velocity of the lander from 30 km height to the final landing, and the ability to reorient the spacecraft from horizontal to vertical direction. This is the trick we have to play here, he said. The velocity at the starting of the landing process is almost 1.68 km per second, but, at this speed, the lander is horizontal to the surface of the moon. The Chandrayaan-3 here is tilted almost 90 degrees, it has to become vertical. So, this whole process of turning from horizontal to vertical is a very interesting calculation mathematically. We have done a lot of simulations. It is here where we had the problem last time, Chandrayaan-2. Somanath explained. After the soft landing, the rover will descend from the lander's belly, onto the moon's surface, using one of its side panels, which will act as a ramp. The lander and rover will have a mission life of 1 lunar day, about 14 Earth days, to study the surroundings there. However, Isro officials do not rule out the possibility of them coming to life for another lunar day. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. After powered descent onto the landing site, there will be deployment of ramp and rover coming out. After this, all the experiments will take place one after the other, all of which have to be completed in just 1 day on the moon, which is 14 days, Somnath had said. Stating that as long as the sun shines, all the systems will have its power, he said. The moment the sun sets, everything will be in pitch darkness. Temperature will go as down as low as -180°C, so it is not possible for the systems to survive, and if it survives further, then we should be happy that once again it has come to life and we will be able to work on the system once again, and we hope like that to happen. Polar regions of the moon are a very different terrain due to the environment and the difficulties they present, and therefore have remained unexplored. All the previous spacecraft to have reached the moon landed in the equatorial region, a few degrees latitude north or south of the lunar equator. The moon's south pole region is also being explored because there could be a possibility of presence of water and permanently shadowed areas around it. The LM has payloads including Rhomba LP, which is to measure the near-surface plasma ions and electrons density and its changes, Chased Chandra's surface thermophysical experiment, to carry out the measurements of thermal properties of lunar surface near polar region, and ILSA, instrument for lunar seismic activity, to measure seismicity around the landing site and delineating the structure of the lunar crust and mantle. The rover, after the soft landing, would ramp down of the lander module and study the surface of the moon through its payload's APXS, alpha particle X-ray spectrometer, to derive the chemical composition and infer mineralogical composition to further enhance understanding of the lunar surface. The rover also has another payload, laser-induced breakdown spectroscope, LIBS, to determine the elemental composition of lunar soil and rocks around the lunar landing site. Ahead of its scheduled landing on the moon, Chandrayaan-3's LM has established a two-way communication with Chandrayaan-2's orbiter, which continues to orbit around the moon. The two-way contact potentially offers ground controllers, MOX Mission Operations Complex in Bengaluru, more channels for communication with Chandrayaan-3. Hi viewers, please support my channel to subscribe, like and share. Thank you all.